Good morning, students. Last class we have finished the theory concepts of electricity chapter. So today in this class we are going to see about some problems of your NCRT textbook as well as exercise. Okay. So I have seen problems up to what Ohm's law, but after that the problems are very much important. Resistors in series, resistors in parallel, specific resistivity. Then after that, electric power, heating effect of electric current. You should remember all these formulas. Okay. So you make a list how to remember the formulas. So I will tell you. It is difficult to remember the formulas if you completely make it in one chart. I will, or if you want to remember it in one shot. So it is very difficult. But rather than that, you make two to three groups such that in first group you remember. So if I say like this, first one, what is my first formula? That is electric current formula. So it is electric current formula. I is equal to Q by T, charge by time. So this is my first formula. You can use capital Q. Second formula is potential difference. V is equal to W by Q. And Ohm's law. V is equal to IR. So these are the three formulas that must be used. Okay. So these three formulas we have seen some last problems on these three formulas. So this is first one. So you can remember in second one. Okay, you make like this and remember in second one which are the some other formulas. After that we'll remember these formulas of resistances. Okay, what is resistance? Rho into L by E. This is one formula. And you make again series resistance Rs equal to R1 plus R2 plus R3 goes like this. And after that you make 1 by Rp is equal to 1 by Rp is equal to 1 by R1 plus 1 by R2 goes like this plus 1 by R3. Okay. So you do the blocks like this, or you can make a rectangle also. In rectangle you remember these formulas, or make a list but make 1, 2, 3 separate. That is first block, and again other block you separate. Or if you are able to remember all the formulas at a stretch, you can remember all the formulas. So third one you can make like this. So I am doing some rectangle here. So you can make four formulas out of this. So third one, so that you make which are those formulas? So heating effect of electric current and power. So heating energy. So let me say H equal to, what is my formula? H is equal to energy is equal to what? It's expressed in joules. So energy is nothing but work done here in this case. So my H is equal to what? I square RT, isn't it? My H is equal to what? I square RT. My H is equal to what? VIT. Or you can make first VIT only. My H is equal to what? VIT. In place of I, if I put IR. In place of V, if I put IR. I square RT. So now in place of this, if I put in place of V by R, that will be my V square T by R, V square T by R. Okay. Similarly, you make the formulas for power also. Just what is power? Energy by time. So heat energy by time. This time will go. Power is equal to what? What is remaining there? I square R, it will come for first formula. Isn't it? This is not needed. Okay. I square R, the first formula will come. Now VIT. So P is equal to VI, or you make this one as first formula. Okay, this is proper one. P is equal to VI. Here also better you write this as first formula, and after that you write this. Here also this one is better, or let me write that in that way only. Okay, so I will write it down. So this is very much important. This third problem is very much important. So this is heat energy and power. So we have three formulas for both the heat energy and power. So H is equal to VIT. So H is equal to, in place of V I input IR. So IR into I into T, that is I square RT. My H is equal to third one V square, if I put here V by R, V square T by R. Now for T, first one T will go off VI. That means what? H by T. What is power? Rate of doing work, or rate of doing work, or rate of consuming of energy. Okay. So rate means it comes in the numerator. So just T will go. H by T is my power, or E by T. So T will go, only VI remains. Here also T will go, only I square R remains. Here also only T will go. So what will be P? P is equal to V square by R. So these formulas you have to remember. Okay. So these are the very important formulas. You should remember these formulas. Okay. You can write them in one chart, or you can separate them. Okay. So apart from this other formulas, if you are able to see, you just write down some formulas, extra formulas, like you can say Q is equal to NE. This is one formula. Okay. So other formulas you can write. So there is no need to worry about that. So I hope you all are aware with these SI units. So please go through them properly. Okay, we'll start problems today. So I'm going to solve some problems. So please note down this, pause the video and note down the formulas. Keep these formulas with you. Okay, in your note. And start solving exercise from now onwards. Okay. Okay. So we'll start today. So problem exercise example 12.6, I think. No, 12.7. 12.7, it is there already in your textbook. Please open the textbook. So we'll see this problem 12.7. So it is a problem says an electric lamp whose resistance is 20 ohm, and electric lamp an electric lamp whose resistance is 20 ohm, whose resistance is 20 ohm, and a conductor of 4 ohm, and a conductor of 4 ohm, and a conductor of 4 ohm resistance are connected to a 6 volt battery. Resistance are connected to a 6 volt battery, connected to a 6 volt battery. Okay. Calculate calculate a the total resistance of the circuit, the total resistance of the circuit, the total resistance of the circuit. B, the current through the circuit. B, the current through the circuit, the current through the circuit. And C, the potential difference of electric lamp and conductor. C, the potential difference, the potential difference, the potential difference across the electric lamp and conductor. Across the electric lamp and conductor. Electric lamp and conductor. Okay, see here. Now they have given the problem. So diagram is also given here. Okay. So I will draw the diagram here. So diagram will be like this. Plus minus. Key ampere will be there. Plus minus. Okay. Then key will be there and resistors will be there. And bulb is there. Okay. This will be my key. So current is flowing in this batch. So this is given in book 6 volt and 4 ampere. 6 volt and 4 ampere we have given minus plus this is key 6 volt, so 4 ohms of resistance. So this is given. So understand the question. An electric lamp whose resistance is 20 ohm. So what is my resistance here? It is 20 ohm. Okay, and a conductor of 4 ohm resistance are connected to a 6 volt battery. So if you see there, what is given first you have to write down. In any problem, so please note down, read the question. As you read the question, please write down the data. What is given there, you have to write down. So as you go on reading the question, just write down the data. So what is my solution here? So what is given? An electric lamp whose resistance is 20 ohm. So resistance is given, R is equal to 20 ohm. So the resistance of bulb is given here. So it is 20 ohm. They have given it. And a conductor of 4 ohm resistance are connected to a 6 volt battery. Conductor of 4 ohm resistance. So this is 4 ohm. This is 20 ohm. Okay. So let me say this is R resistance. R1, R2 is 4. So this is R2, or say let this be R2, R1 be 4. This is R1, this is R2. Okay. Now see here. Connected to 6 volt battery. Potential difference is 6 volt. Calculate the total resistance of the circuit. B. The current through the circuit. C. The potential difference across the circuit. See here. First, what is happening? So, bulb is also a resistor. You should remember this. Bulb is also a resistor. So, 4 ohm and 20 ohm, they are in series. So, I have to find out very easily the total resistance of the circuit. First, my A is total resistance of the circuit, that is RS. That RS is equal to R1 plus R2. What is my R1? 4 plus R2, 20. 4 plus 20 is 24 ohm. I hope you are getting my point. So, bulb is also a resistor. No need to worry about that. Bulb, TV, fan, these are also called as resistors. Here two resistors are in series, means the total resistance of the circuit is nothing but addition. They are in series. They are in end-to-end connection. They are not parallel. They are in end-to-end connections, means they are in series. When they are in series, what happens? Total resistance of the circuit is nothing but both the resistances will add together. So both the resistances are add together when they are in series. So bulb is also a resistor. So now if you add them, 4 ohm plus 20 ohm becomes 24 ohm. See the second question. The current through the circuit. We need to find out what is the current through the circuit. So total resistance we have got. To need to the current through the circuit, what we have to do? We have to consider total resistance. So Rs is equal to 24 ohm. So I need to find out the current through the circuit. So what is my B? Current through the circuit I is equal to V by R. So how we know that? V is equal to IR. So I should be equal to V by R. So what is my B here? See, V is how much? 6. R is total effective resistance you have to take. 20 by 24, 6 by 24 is 1 za 4 za. So 1 by 4, so if you put it in number, decimals, 0.25 amperes. I hope you all are clear. 0.24 amperes. So third one, C. The potential difference across the electric lamp and conductor. See, the current 0.25 ampere will be same in 4 ohm resistor and 20 ohm resistor also. Why it will be same? Because in series circuit the electric current will be same, isn't it? The electric current will be same in series circuit. So 4 ohm resistor is also having 0.25 ampere current. 20 ohm resistor is also having, that means lamp is also having the same current, but the potential difference divides in series circuit. In parallel potential difference is same, current divides there. So now I have to find out the potential difference, that is voltage across both lamp and conductor. So for lamp R2, for conductor R1. Okay, R1 is the conductor or resistor, you can say. See, so potential difference across R1 will take, that is V1. Potential difference across 4 ohm resistor, that is, what is my V? IR, but R is here R1. Okay, so V1 is equal to IR1. So IR1 means what is, we have got 0.25. R1 means how much we got? 4. 4 into 0.25 is 1 volt, isn't it? 0.25 into 4 is 1. 25 4 is 100. 0.25 into 4 is 1.00. That means 1 it is. 1 volt. You have to take it as 1 volt. So what is my V2? Similarly, IR2. What it will be? IR2. What is my I here? We have already found here 0.25 into R2. What is my R2? 20 ohm. Isn't it? 20 into 0.25. That will be 5. How you know that? 0.25 will make 1 by 4 also. 4 on the 4 by the. So that is our 5 volt V2. So this way we have to solve this problem. I hope you all have done with this problem. Very easy it is. It is already in your text. So please note down this problem and write down the answers. Okay. So take care about this. Understand the problem. As you go on reading the problem, please note down the data. Depending upon the data, think which formula needs to be used to find out given question. Okay, so I hope you all are clear with this. This is regarding series resistances. Okay, so we'll move to the next problem, that is resistors in parallel. I hope you all are clear. Please note down. Okay, pause the video and you can note down. So we'll move to the problem number 2. We'll move to problem number 2. So what is my problem number 2? So again from text we'll see that. So how many problems we have finished there, that is different. So now we'll make this one as different, or you can, if you want to continue, you can continue. So till Ohm's law, how many problems are finished? Maybe 6 or 7. You add 8 or something like this in the continuation, or you can say you just continue this part, example 2, example 2 part as 1 2 like this. Okay, we will continue this resistors in parallel problem, that is example 12.8. So it is in the circuit diagram given in figure 12.10. So if you are having textbook, please read the problem. In the circuit diagram given in figure 12.10. 12.10 means the circuit below, before that, in the page 213. Suppose the resistors R1, R2 and R3 have the values 5 ohm, 10 ohm, 30 ohm respectively. Okay. The resistors R1, R2 and R3 have the values 5 ohm, 10 ohm, 30 ohm respectively, which have been connected to a battery of 12 volt. Which have been connected to a battery of 12 volt. Calculate the current through each resistor, B the total current in the circuit, and C total circuit resistance. Okay. So you note down the problem from text only, or shall I need to write? So better you note down from the text. I will write only data. Given what is given, I will write. So you note down the problem from from the book. Okay. So only I will write the data. Calculate the current through resistor they have asked. Okay. First, what is given? So R1 they have given as 5 ohm. R2 they have given. R2 what they have given? 10 ohm. R3 they have given 30 ohm. Okay. R1 they have given 10 ohm. R2 they have given 10 ohm. Sorry, R1 5 ohm, R2 10 ohm, and R3 30 ohm. Okay. But shall I need to write the problem also? Better I will write it. So okay. You try this problem. Better you try this problem. Please go through the problem. Try this problem. I will write it on the board. Along with me, you try this problem. Problem, this one is number you can put in the circuit diagram. In the circuit diagram. In the circuit diagram given in figure 12.10. Given in figure 12.10. 12.10. Suppose the resistors are 1. Suppose the resistors. Suppose the resistors R1, R2 and R3 have the R1, R2 and R3 have the values. Have the values 5 ohm, 10 ohm, 30 ohm respectively. Which have been connected to a battery of 12 volt. Which have been connected to a battery of 12 volt. Which have been connected to a battery of 12 volt. Calculate A the current through each resistor. A the current through each resistor. The current through each resistor. B the total current in the circuit. B the total current. Please note, write down with me. Just don't simply sit. Please write down with me. B, the total current in the circuit, and C, the total circuit resistance. C, the total circuit resistance. The total circuit resistance. So diagram we have to take down. How is the diagram? So diagram, please note down this diagram. Okay. So this is the diagram. Plus minus. Key is there. Ammeter is there. Ammeter, that is minus plus. So three parallel resistors LPS, LM, PQ, SC. Okay, three, and these are connected to a voltage, that is voltmeter. Okay, this is like this LM, PQ, ST, XY. So it is taken on. So current will go like this, and it will come like this, and it will go. Okay. So this is my X, this is my Y. Here are 3 points L, M, and PQ, ST. This is the diagram. PQ, ST. So I hope you all are clear. Plus, minus. So plus, minus. So what is they have asked? So this is plus, this is minus. Okay. So see the diagram, the circuit diagram given in the figure 12.10. Suppose resistor R1, R2, R3 on the values 5 ohm, 10 ohm, 30 ohm. See, this is having 5 ohm, this is having 10 ohm, this is having 30 ohm, respectively. Okay. So what you need to find out? Calculate the current through the resistor. That means you have to find out if I is going I1, I2, I3. You need to find out. With 5 ohm, what is my I1? With 10 ohm, what is my I2? And with 30 ohm, what is my I3? You need to find out the total current in the circuit. So after that, you have to find out what is my I. Okay, we found before in the first question we found I1, I2, I3. Just add them, you will get I. Third one, the total circuit resistance. So they are in parallel. They are in parallel means you have to find out 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So we can find like that way. So I hope I have given some hints. So I will solve this problem in the next class. But you try. Okay, you try to solve all the ABC 3 problems. Okay. So let me see who will or who all will solve. So however, if you after solving the problem, please send me in WhatsApp. Okay. However, I will solve this problem in the next class. So please compare your answers with my answers. That is in the next class. I hope you all are clear with how to solve this problem. So very much easy it is. The current through each resistor you have to find out. See here, voltage is R3 which have been connected to a battery of 12 volts. Voltage is given here. So this is 12 volt. So battery 12 volt they have given. Very easily you can find out. The same 12 volt is applicable for R1, R2 and R3. So you can find out I1 here, I2 here, I3 here by using Ohm's law formula. Okay. And after when you got I1, I2, I3, you just find out I is equal to I1 plus I2 plus I3 because it is only divided. When you find I, it is easy that you find the total circuit resistance. How you will find out? By using the formula V equal to IR in one way, or other way you can also find out 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Same answer will come for both the problems. Okay, in both the methods. So you try this. However, I will solve the problem in the next class. I hope you all are clear with this. So it is already in textbook, in NCERT textbook it is there. So you try to solve this problem and send me in WhatsApp the answer. And next class I will solve this problem and check your answers. Thank you.